Hi everybody, Newland. Let's talk about the dot product and the cross product. The dot product is known as the scalar product, and the cross product is known as the vector product. And let's get into some of what that means. So I've got vectors A and B, and notice I don't have to have them lined up the way they are lined up here. It makes it easier to think about the geometry, but A and B could really be anywhere. They don't have to share a common origin. Vectors don't have to be in one place to represent that vector quantity. But I think I'm going to leave them along the x-axis and y-axis. I mean, let them overlap one another, so it makes it easier to describe what's going on. Notice A, I've specifically only put in the x-axis. Its y component, if I click on it, you can see the y component is 0, the x component is 10, its angle with the x-axis is 0, and then its length is just 10 because that's ax. And if I click on B, its x component is 8, its y component is 9, so x is 8, y is 9, its length is 12. The angle between the vector and the x-axis is 48.4 degrees. And I'm going to drag B so that it sits on top of A because I want to describe the dot product first, which is a scalar, and the cross product next. So dot product says that the length of A times the length of B, the length of A, times the length of B that's parallel to A. So let me say that again. The length of A times the length of B that's parallel to A. So this quantity here. So that's 8 times 10, that's 80. So that quantity has some specific meaning when we get to the topic of energy. It's important to know it isn't a vector, it is a scalar. So what we're doing though is we're only talking about the part of B that's parallel to A. So in this case, the part of B that's along the x-axis, which is the x component. So that's just 8 times 10, that's 80. We'll come back to what that means in a minute. The cross product is the part of B that's perpendicular to A multiplied by the length of A. So if I drag this up a little bit, the part of B that's perpendicular, in this case, that's the Y component. It's a lot easier to think about the cross product when they're lined up like this because it's easy to tell which one is X and which one is Y. You don't have to worry about the orthogonality if you know one is X and one is Y. So here, the cross product would be 9 times the length of A. So that's 90. So the dot product would be 80 and the cross product would be 90. The cross product will have physical meaning when we get to the idea of rotation, and it is a vector. So when you're trying, if you think about like turning a doorknob or grabbing a screwdriver and like screwing a Phillips screw into like a piece of wood. The rotation is a vector because it does matter. It can be clockwise or counterclockwise, but we're getting ahead of ourselves. Let's stick with dot product for now, and which is a scalar, and then we'll talk about cross product, which is a vector. Okay, so I've got an A and B in their components, and I'm gonna let's just write down the definition, the mathematical definition of A vector dotted with B vector. Notice I drew a big fat dot to indicate that this is a dot product, which is a scalar. That's the length of A times the length of B. Notice I'm using the absolute value bars around it, times the cosine of the angle between it. Remember, it's so that's really the way I've drawn this right now. That's B cosine theta. That's the X component, B cosine theta. So, but the definition of dot product is even if A and B are not lined up along the axes, then the length of A times the length of B times the cosine of the angle between the two vectors, that's the definition of the dot product. And again, it will have physical meaning eventually when we get to the idea of energy. By the way, I will often write this as just A times B times cosine of theta, and I'll drop the absolute value bars and a little arrow so that now that I've done that, I know this is a scalar quantity, and it's, not that I don't have to worry too much about the direction anymore because now it's just a magnitude, okay? So you can also write this as the product, the sum of the product of the components. And what I mean by that is I can say AX times BX plus AY times BY. Now in this case, A had no piece in the Y direction. So this thing just turns out to be 0, but this can be a very mathematically helpful relationship. You know that A dot B means something, and you can write it like this, but it's the length of A times the length of B times cosine of theta, but it's also the sum of the product of the components. So the x's multiplied together added to the y's multiplied together. Okay, and that can be a really useful trick. Okay, so let's try and draw this again. Here's our A vector. not quite as good as my phet representation. There's the b vector, and there's the angle theta between them. Okay, so what we want to do, let's go actually over to Desmos and do that. So wait, I don't know if I have the right numbers. B is 12. Okay, I got that in there. B is 12, and the angle is 48.4. Oh, I do have that right. So I put theta 1 in here. I put the length of A, which is 10. I put the length of B, which is 12. I put the length of the x component, which in this case, all of A is in the x direction. So AX is just 10. AY is 0. None of A is in the Y direction. So I went ahead and wrote it in there to be explicit. You don't have to do it, but it's just for this definition purposes. And then I found the X component of B, which is the length of B times cosine of the angle. And I found the Y component, which is B sine theta, which I don't even need this part. This B sine theta, I don't need that for the dot product. I will need it for the cross product. So here I decided to try it out. AB cosine theta, I got 79.67. And then I tried adding together the product of the components. I got 79.67. So they're the exact same quantity. So again, the dot product is a scalar, and it has physical meaning when we get to energy. The cross product is a little bit different. Let's actually start with this. The cross product is the y component of B. So whatever part of B is perpendicular to A. For the cross product, you care about how much of B is perpendicular to A. For the dot product, I care about how much of B is parallel to A. So they're not the same quantity, and they even have different physical meaning. Okay, so let's figure that out. So I said that the cross product, so this is written even in a different way, A cross B, a big X like that. And this equals the length of A times the length of B times sine of the angle between them. But there's also another thing to worry about, and that's we have to consider the fact that when we multiply these two quantities together, the answer is a vector. So we're going to have to think about something called the unit vector. So that would be A hat cross B hat. And that's its own tricky, you know, rigmarole. But forgetting the direction for a minute, if we just needed to know the magnitude of A cross B, you can do that with Desmos as well. And that would be, well, it's the same deal as before, by the way. You can multiply by the sine of the angle between them. So again, we're going to forget the cross product for a minute, and we're just going to multiply the length of A. So I guess we could write this as the length of A times the length of B times sine of the angle between them, and then there's going to be an A hat cross B hat. So you need to do this, by the way. The easiest way to do this in Physics C is something called the right hand rule, which if you know how a corkscrew works, or you're like screwing a Phillips head screwdriver, uh, a screw with a Phillips head screwdriver in a piece of wood, you notice that if you go clockwise, it does one thing. If you go counterclockwise, it does another. That is the right-hand rule. And that is actually directly related to the cross product. The cross product will show up when we get to rotational force, which is known as torque. So they actually, you know, like have some real meaning. But if you needed to just find the value of the cross product, it's A times B times sine. Oh, not the integral. Sine. Sorry. Sine A times B times. Desmos is too smart for me. Theta 1. Sorry about that. I think it thought I was trying to. It does. It thinks I'm trying to find the absolute value. So you can see that the cross product is around 90. The dot product is around 80. So it does exactly as we expected it to do. And these guys are the same quantity, so that makes good sense. But the dot product is actually, in this case, smaller than the cross product. And that mainly has to do with the angle between them. If I make the angle bigger, I'll increase the dot product. I'm sorry, if I increase the angle, I make the cross product bigger because I'm making the y component bigger. But if I drag this down some, now I've made B's x component larger. So the angle really impacts which of the two components of x are going to be bigger. Okay, so that's not a bad introduction to dot product and cross product.